Last Friday, Elon Musk showed off FSD12, which is a fully end-to-end neural net. We want to talk about this for two reasons. One is we believe this is nothing short of revolutionary because this is really where AI is going, and in our opinion, AI will succeed. It's like Jitendra Malik says, it matters what cats know and not what logic can do. And what that means is that you have an end-to-end learning of robots algorithms that help it learn are not explicitly programmed. So they're not programmed in a way where you tell it, listen, this is a stop sign, this is how you should behave. Hey, listen, this is a roundabout. It's not like that. It is, you put the thing in the world, it keeps learning by observing other people or other robots in the future, and then acts accordingly and therefore learns. The powerful thing about end-to-end learning is that it can keep learning and that it doesn't require human intervention in future learning. In other words, it's much, much more scalable. This is a Not Even Wrong podcast. It's August 30th, 2023. This is Krim Delco. Since the last update, we're up 15%. The market's up 2.5%. For the year, we're up 121.2%. The market's up 17.1%. We're up from 104.1%. 104.1%. And the main outperformance came from Tesla. We believe that there has been some good news in China, which drove the stock up. We also had actually the FSD performance, which has gotten mixed results. So we don't want to necessarily put it up there as the main reason, but we believe that this is, of course, a massive, massive driver of the stock going forward. Now, let's talk about what this actually means. At the Not Even Wrong podcast, we've spoken a lot about FSD for years, and we've said that end-to-end learning is the future. End-to-end learning is where AI is going to go or has to go. There's two components to this. One is the fact that we have a robot which is navigating through nature and learning what to do. And the next one is that this is happening end to end. So these are two distinct things that are, of course, tightly knit together. What does it mean navigating through nature? Well, there are AIs, the AIs that we look at, typically the Googles and the Facebooks and the Instagrams and the Snapchats, that are all using AI, the recommendation system in Amazon and so on and so forth. All of these AIs are looking at a very specific problem, which is, in a nutshell, manipulating humans. I mean, that's fundamentally the goal of these AIs. The actual goal of an FSD or a future robot, humanoid robot, or whatever you want to call that, is not to, the actual goal there is not to manipulate humans. It is for the thing to be able to navigate through the world in an intelligent way, by solving problems, by realizing, what it has to do and how it has to do it, and so on and so forth. Now, the second thing is that this is happening in an end-to-end context. What that means is that we have, I can't emphasize this enough. Okay, we have an algorithm which has no explicit programming. There's nothing tells it this is a stop sign, this is a green light, this is a red light. None of that stuff. All it does, it curates the data in a way that the data feeds the algorithm, and then the algorithm updates the weights, and the next time the robot is exposed to a certain situation, it acts accordingly. This is the key of end-to-end. The advantage of end-to-end is two. One is it keeps getting better and better, and second, it's scalable. That's the key. Scalable in the sense that because we don't have human intervention, we can have a car, go to Alaska and learn how to drive. A car can go to Switzerland, New York City, and the more you drive it, the faster you learn. Now, there's caveats here. One is that the try and error, the fail, which is very important in learning, is of course very difficult. We can't have accidents happening at scale, of course. So that is one caveat here. That's why we've been advocating for an animation solution. Because what you would like to see ideally is that the robot starts learning and getting better than humans. So it doesn't just learn from humans. It does it in a self-play way, a little bit like AlphaGo Zero. But for that to happen, the robot has to start driving and learning on its own, and that of course will imply many accidents before it gets better. Also, right now the objective function is which is a good question, actually, be a good question for Ashok or Elon Musk. But what exactly is the objective function? Is it just to mimic humans as well as possible? It's probably something like that. And, human driving is what we're exposed to, and it's not perfect, but human driving is the standard. So no matter if you like it or not, human driving is the standard that everybody will measure FSD against. And also, of course, NHTSA, which is important, the regulators will measure it against human driving. What I'm trying to point out here is that we could actually have a situation where the robot gets better even than humans, and does certain things even more intelligently than humans would do it. Does certain moves that you wouldn't expect. The typical move would be, if I go from here to Palo Alto, from my home to Palo Alto, I would take a route that maybe a human would never take, but it has already anticipated, based on some weird intelligence that it has developed, that there will be an accident. It can anticipate accidents based on data that it's reading from God knows what, and we humans don't have that type of intelligence. Or it could drive and avoid an accident in a very weird way that we humans would never do. So things along those lines. That's why I'm saying AlphaGo Zero had that same effect. It surprised people at DeepMind that it was able to do things that humans would have never done, and it would have done this. It did this because it had the ability to self-learn over billions of iterations. The future of that kind of thing, I can't see this right now happening with FSD, just because we don't have the ability to self-play. We don't have the ability to try and error multiple times until we actually get to a solution that is acceptable, other than in animation mode. But let's get back to where we are today. In reality, FSD is what we're exposed to as a society, as a species, as investors. And what that is a robot. It's a car that is driving around, and it's copying humans. So it's looking at what humans are doing, and it's trying to do as well as it can based on that. So if humans stop at a stop sign, so does the robot. If humans turn left when the arrow is green on the left, it will keep doing that. When humans slow down because there is an old person crossing the road, even though there is no pedestrian zone, it will slow down, because that's what people typically do. The skill here is, and Ashok said that on that particular, you have to think about it this way, okay? The skill, what is the skill involved? Well, one is, of course, you have to build that algorithm. Now, the algorithm itself is probably, I would say, half the solution, and you can get better at the algorithm building. But what's really important, what's really, I would think, the most important piece of the puzzle here is the data curation. What does that mean? It means that, okay, what kind of data do I feed the system so it can learn most effectively? And that's where the explicit code goes from the actual algorithm, which is, there's no, the actual decision making, the inference, the translation from learning into action, which is called inference. That has very little explicit code. There's no more if this, then that, and so on and so forth. But the data curation will require a lot of explicit coding and also explicit thinking. So I would think that the future of full self-drive will morph into more, okay, what kind of data do we feed the car, and also how do we find that data? Okay, how do we decide which data is worth feeding the algorithm? Should we have the edge case where a drunken person starts playing electric guitar in the middle of a highway? Yeah, probably not, right? But the old person crossing the street, even though it's not a pedestrian zone, yes, that is probably worth our while teaching the system. And then we have, the right turn. It's a good example. Right turns are allowed in California. They're not allowed in many other places. Well, obviously, that's something we need to teach the system. And also, how do we teach the system that right turns are allowed in California, but not in New York City? It's incredibly. It's possible that somebody drives from California to New York City with a Tesla, so that car better knows what the rules are in the different jurisdictions. So those are the kinds of things that we're looking at as investors, that we're looking at as investors in AI. Our main goal here at Orange Capital Partners is to create wealth by investing in fundamentally new concepts and engineering practices. And AI, real world AI, this is the opportunity of our generation. Our largest position is Tesla, our second largest position is NVIDIA, and those are the two only positions we have, because we believe that both of these companies are well positioned to drive AI, in particular, real world AI. There's nothing wrong with the non-real world AI. Would be Google, would be Facebook. That's manipulating humans. It's the imitation game. It's literally what Alan Turing wanted to achieve. We've spoken about this. It is the game, the imitation game. The imitation game is the idea that we build an intelligence that can manipulate humans. That is the goal of the AI as we had known it so far. The new type of AI, the AI that we actually care about, is the real world AI, which is what matters is what the cat knows. What matters is what the machine learns by doing stuff, and not what we tell it to do. It's not what logic can do. It's what cats know. This is, Jitendra Malik's quote from the Peter Beale podcast that we spoke about not too long ago. That's what matters. That's where we live at Orange Capital Partners. That is our goal, to generate wealth by investing in this type of artificial intelligence. We believe this is the path towards intelligence. So it's not just artificial intelligence per se, or it is actually the path towards a new type of intelligence, an intelligence that will surprise us, that will give us enormous amounts of economic growth. It will free us from manual labor, driving a car. The humanoid robot will do a lot of manual stuff, take a tool from X to B, that kind of thing. But these are just the beginnings. I mean, think about it. If you had looked at the imitation game and the idea of universal computing and those sort of things during the times of Alan Turing, you would not have predicted even close to what was to come in the next 50 years, 100 years. I think it's a fair guess to say that we will have a lot more innovation, a lot more economic growth, a lot more everything going forward, assuming, of course, these technologies have legs, and they will have legs. They already have legs. This is not an if question. This is a when. And this particular presentation by Tesla last Friday, I think will go in the history books as one of those events that has set the stage for a new kind of AI, for a new kind of intelligence, for a new kind of also process and development of intelligence, and all those sort of things. That's why we believe this was so important. And not the first time that Tesla sets the stage for important things to come. Obviously, they've done this before with electric cars. When the Model S was launched, this was the beginning of what we believe has been the future of transportation. We said it, back then. I don't know if maybe it was a tweet or something. Wolfsburg, we have a problem when the Model S was launched, and well, that turned out to be true. Wolfsburg has a problem. It took quite some time. Took much longer than we thought it would take, but in the end, actually, it didn't take that long. It's like the typical thing with technology. You overestimate it in the short run and you underestimate it in the long run. This is what is happening now with electric cars. I think people are still realizing what this means, and also they're not realizing what it means for Tesla and wealth creation per se. But that's for another podcast. So to summarize, the FSD presentation last Friday by Tesla was a pivotal moment in the history of mankind, in the history of technology, in the history of business. It's nothing short of that, because it shows the path towards an intelligence that learns end-to-end, that is not explicitly programmed. That means that it's scalable. That means that it will be able to learn faster and more effectively going forward. That it doesn't need humans. It doesn't need things like, particularly not explicit programming, which is, of course, the bottleneck. That's hard to do. It is much, much more efficient or scalable, or whatever word you want to use, to put to curate the data and have the data teach the machine how to deal with a stop sign, or how to deal with a pedestrian, and all those things that driving around in traffic entails. It's important because it's scalable in two ways. One way, we can do a lot more. We can have cars doing all kinds of maneuvers that we don't have to anticipate. And second, it's scalable, and this is the really important thing, because it learns. It learns by itself. And therefore, it can solve problems going forward, which is really the key of real-world intelligence. Thank you.